Welcome back guys to a brand new video. Previously I've purchased a Vevor quick change tool post. Now you can see it just behind me on the lathe there. One thing that I've noticed that it didn't come with, which would be ideal, is a top spanner or handle for the top of the quick change tool post to allow it to spin and then lock it back up. I have been using a 26mm ring spanner, but that isn't ideal because I have to steal it from my toolbox that's just over there. And in this video, I'll be making my very own top handle and it will be permanently mounted. So let's get into the video. After sorting through my metal offcuts, I located two pieces of mild steel round bar, one measuring at 43.6mm in diameter and the other just over 20mm. The design I'm aiming for is very straightforward, a simple handle with an M10 thread. The nut section will feature an M16 by 2mm internal thread, along with an M10 internal thread to match the handle. Here I'm demonstrating my vision for the design. As with many of my previous projects, there's no formal drawing. I'm approaching it intuitively and letting the process guide me, with the aim of achieving a satisfying end result. The first step in the process is to load the larger round bar into the chuck. Since I was working with a small offcut, setting it up in the lathe with enough clearance was a bit challenging, but I managed to make it work in the end. If you're thinking, wow, that Hafco AL320G lathe sounds quiet, I recommend checking out my previous video where I explained how I achieved it. While the method I used stirred some debate, the noticeably softer sound speaks for itself. As with many projects, the process typically begins with a quick facing cut followed by drilling a center point to guide the subsequent operations. With that step complete, it's time to use the spanner to remove the top nut. Ironically, the very task this entire project is designed to improve. You might expect an M16 bolt to measure exactly 16mm, but in this case, it comes in at 15.6mm. The next step is to drill out the internal diameter to suit the M16 tap. This is usually the point in the video where the comments start asking why I'm not using single point threading, and the honest answer is, I just can't be bothered setting it up. The thread I'm cutting is an M16 by 2mm. Here I'm loading a 14mm drill bit, which is the appropriate size for the tapping process that follows. It's times like these where I wish I had a DRO for the tailstock. For now, I guess the Sharpie method will have to do. Time for some chamfering and then it's on to the threading of this component. Although a spiral flute tap would have been a lot more suitable for this, unfortunately I don't currently have one in this size. Due to the large size of this thread that's needing to be cut, I came up with this method to stabilize the tap while using a lot of my strength to wind it into the workpiece. There are definitely going to be comments saying that I should have used a tap follower. I do agree, although it's another tool on my to make list, so keep an eye out for that one coming soon. Now that the lower chamfer has been added, it's time to do a test fit. I'd definitely call that a success. Now it's time to flip the part in the lathe and tidy up the top side. One thing I might add when using offcuts for projects, it's quite time consuming to have to face the part until the center point hole from another project no longer exists. That felt like it took forever, but I finally achieved a smooth surface with no hole in the middle. More chamfering for aesthetic purposes, then onto some quick sanding to finish it off. Here I'm marking the placement for the handle. I want it around out of the way so it doesn't clash into the other one. It's moments like these where I wish I had have considered the angle of the handle as well. You will find out later in the video of how this played out. Due to not having a tap follower, I lightly place the tap into a collet and feed it into the workpiece. I find this gets a decent start and keeps it relatively straight for winding it in by hand. That's part 1 of 2 completed. Next up is to make the handle that will have an outer M10 thread on one end. Here I'm marking out the portion that will have an M10 thread cut. This section will allow the handle to screw into the other part that I made previously. I turned the outer diameter down to 8.5mm. The thread is an M10 by 1.5mm. For those with a keen eye for detail, you will notice I selected the wrong die. I noticed this later when the handle didn't screw in. Luckily, it was an easy fix. If anyone is wondering what this contraption is, it's a die follower. I made this in a previous video. If you're interested in how it was made, be sure to check that video out. I chose not to power feed the die follower onto the workpiece as the threaded section wasn't very long. With one hand on the chuck and the other turning the die follower, it made easy work of this part of the build. After taking a look at the section on the end that was originally held in the chuck, I decided to keep it as it was very similar to the stylings of the other handle on this tool post. All I needed to do was clean it up a little and we're done. The handle has come out quite nice. Although it is very basic with no knurling, it will match the other handle just fine. Next up is to go over to the mill and create a section that will allow the handle to be tightened with a spanner. I've marked with a Sharpie where I want to make a 2mm depth of cut. I hope to be able to rotate the part 180 degrees and do the same pass that will then equal a 14mm wide portion for the spanner. If you're wondering what that rattle is, rest easy, as it's only the upper cover for the motor belts and pulleys. It's definitely something I will need to address in the future. I think that has come out alright considering I eyeballed a lot of the measurements in. There are still so many upgrades and tools I need to improve my processes when making things like this. Can you guess what's about to happen? This is that moment where I officially hit struggle street with this project. It happens basically with every project, but we push on and work through the issue to get a positive result. And there it is. Due to not angling the handle upwards, it now clashes with the other one. I stared at this for quite a while, and what I came up with was to redo the handle thread at an angle and to make it further around just a little. For the remaining thread that won't be used, I'll weld up the hole and machine it smooth. It will be like it never existed. Here I'll use my angle finder and then transfer the angle over onto the workpiece when I clamp it down in the mill. Hopefully when I drill and tap the thread, the outcome will be better than what was just shown. This is some MIG torch nozzle paste to stop the splatter sticking. Hopefully this will stop anything sticking to the thread for the handle. This setup wasn't ideal. I struggled to get the part to spin concentric, so I came up with another method to get the job done. This involved tightening down the workpiece on an M16 thread that originally came with the tool post. This is another one of those moments where you learn something new. I quickly found out how much carbide tips dislike interrupted cuts. Luckily, most of the weld had been removed and the next few passes will be a lot more consistent. So there it is, guys. That is the final product. I'm very happy with how it has turned out. Time to take it over to the lathe and show it in action. Well guys, that's a wrap for this video. That is the upper lock handle for my quick change tool post. I really hope that it inspires you to maybe make one for yourself. It is going to improve the efficiency of me using this quick change tool post because it is permanently mounted, where before I was using the spanner, I would lose it like I always do with all my other tools, and it would just waste time trying to find it. So because it's permanently mounted, in my opinion, that is way better. If you watched the whole video through, you would have seen me make a mistake. Normally I would have cut that out, but I just thought I would show you in this video just for transparency, and all of you can see me hit struggle street like I always do at least one time in these videos that I make. So remember to like, subscribe, comment down below if you like the video, and until next time, I'll see you in the next one.